Okay, so let's check you're in the right room. We're going to talk about REST APIs. This is tips for designing and consuming public APIs. Who was in Matt Varga's talk about TypeScript and GraphQL? Anyone? Ooh, only a few. He basically said in the middle of the GraphQL bit, REST is dead, and there's no point of REST, right? I'm obviously coming from the other side. There is no one solution for APIs anyway, so I don't have this belief that GraphQL is a bad thing. The question is, how many of you in the audience have to create an API for someone to use? Woo! And that's for external customers rather than internal. Yeah, who's got externals? Yeah, because that's the really important bit. I think one of the things I would caveat this talk with is if you're going to write a REST API, you have to have a good reason, and it's external users. It is not internal users. Internal users could be dealt with in a more simpler way. If you own the whole code base, you have a much easier job with an API, because when you change it, you can change all the users, people using it. So the consumers are easier to change. So why should I be talking about this? Well, I'm head of engineering at Huddle, which is a secure document collaboration system in London. We have a public API that's used by at least 30 different customers we have, as well as ourselves. That's in the last week before I checked the API requests and found the clients who were talking to us. When I'm not working at Huddle, I'm commuting to work on a bicycle with a London A to Z top. People won't remember that. It was a book in London for showing you how to get around London, but you don't need that anymore because you use a phone. So it's now only sellable on a t-shirt. And if I'd have brought my bike, I would have definitely hooked it up to this very cool cycle rack on the riverfront in Porto outside the hotel, because that is one mean cycle rack. But anyway, that's enough of me. So the question is, when you talk about REST, it's like talking about Agile. If you talk about Agile, people go, what do you mean by Agile? And the same thing comes with REST. What do we mean by REST? Because there's lots of people's different views of what REST is. If you go back to the original proposal from Roy Fielding in a doctorate, so it's only, 18 years old, this kind of concept of REST. One of the things, who's heard of HATEOAS? Yeah, they don't like the word hate in an acronym, so they've decided to call it Hypermedia API. And there's something called the Richardson maturity model. Anyone heard of that? It used to be an interview question for developers, a very sad thing to do to developers. So that took the idea of what's your flavor of REST? Is it a URI? Another level is using verbs. Another level is the formatting and the hyperlinks. So there were these various levels of REST. But if you take Roy Fielding's view, he said hypermedia is an essential in REST. If you aren't doing hypermedia, in other words, if you're not doing links in your document that tell you where to go next, you're not doing REST properly. Now, we have these discussions at work about how to design REST APIs, and people have different views, and you get arguments with RESTafarians. No? Anyone? No. I'd gone to Barbados when I first created this slide deck. And they argue about exactly which verb should be used, what the resource should be. But the key bit to remember is that thing about hypermedia being in there. And the other thing to remember, when you design a web API, the data model, which you have in your database, is probably not the object model you have in your code, in your services, in your back end. And it should not be your resource model that's displayed in the API. There is no reason that just because you have a table in the database called user, that you have a URI called user/123 to get a user, and it gives you every bit of data out of that data table. If you do that, you're coupling your REST API to your database schema. And that's the last thing you really need to do, because it makes it very hard for you to change your database schema in the long run. So it's not CRUD. And the first time I hit REST, I went, well, there's get, delete, post, put. It's like doing an insert, an update, a delete, and a select. But it's not the same thing at all. And if you start from that, life's a lot easier. If you can decouple the idea that your API is not your database table. So what's a REST request? It's generally a HTTP operation. I put a little asterisk on that because someone pointed out it could be SMTP or FTP or AMQP. Virtually everyone in here, anyone used anything other than HTTP, HTTPS to talk to REST? No one. So theoretically possible, no one does it. So if we talk about HTTP, this is the kind of thing you're used to having. So you would send this request to a web server. It's composed of a verb. In this case, it's get. It's got a resource. So for Huddle, this is our API to get the most recent documents you've looked at in our system. So it's to do with files, but it's based on a user. The user's ID is 123, and the resource we're after is recent items for user 123, and it's going to be a list of files. That's what that resource is really explaining that's why it's formatted like that. And then you have headers. We have authorization, so we can trust the person. We're not just going to hand over information willy-nilly. We have the content that's going to come back. So you're saying, I'd like it coming back in JSON. You could also put, I'd like it to come back in XML if you're really a sadomasochist. But if you want something you can read, it's JSON normally. And you might have caching headers, like if modified since. And if you're doing posts and puts, you'll be putting data in the body of the request as well. So we might have JSON that updates an object or creates an object. And what do you get back? You get back a much longer response. Hopefully people can still read it. So you probably get back a status. If you were getting an item, you get 200 OK, saying, yeah, everything worked. 300s are kind of caching things. 400s are to do with, what are they to do with? God. 500s are server errors. 400s are client errors in general. Headers, we've got content type, last modified. So it's telling you what the content's going to be in the body. It's giving you some caching information. More importantly, we've got JSON or XML or plain text or CSV or anything. Nothing says it has to be JSON coming back. If you had a REST API that wanted to get back images for putting user avatars, you're going to return a JPEG or a PNG image. And a set of links. And this is where we really get into what REST is. It's this Hypermedia API links. So by getting this request, we know we have a document. And if we want to delete it, we can issue a delete to the item on the list. There is a self that gets you the document. So there is an alternate. The alternate in the case of Huddle is if you use that URI, you leave the REST API and you go to the website. So we can happily, inside a client, say, if you click on this, we can go to the website and look at that item. And that's what this thing about Hypermedia is. Hypermedia you use all the time. When you go to a website, whether for me, if I went to BBC for the news, I don't know every link that's on that page. It hands me a link with all the links. It hands me a page with all the links to the news stories that I want to go to. I click on them. That goes to another page that has a set of links under it. I click on them, and half an hour later, I've lost, track of time, and I'm not doing my job, and I'm just surfing some latest celebrity gossip. So now, when we talk about REST, someone will mention gRPC. Anyone use gRPC? One person? Ooh, only one. Wow. This is remote procedure call created by Google, so it's always connected, which is quite a neat trick. It's binary protocol, generally, and procedure-based rather than resource-based. Now, RPC, we've done before in the industry. Anyone done Java RMI or DCOM? Yeah. You don't know how painful it was, man. You weren't there. DCOM was an absolute nightmare to manage, right? The idea, it sounds really good in general, that I can talk to an object on my machine, and it's on that some machine somewhere out there, and it's remotely called as if it's on my local machine. And I don't have to worry about the network, and I don't have to worry about latency, and I don't have to worry about all this. I can just call it like it's a normal object. The problem is, if you're on a mobile client, you have got latency, you have got a network that goes on and off, and you really don't want to be doing RPC if you could help it. So it really was painful, DCOM. I know gRPC will have solved some things, but I still wouldn't like to go back there. So where do you start? So we said we'd like to go RESTful. We know that resources are not the same as your database. So clearly what we want to do is get straight into the code. No. Bad move, I think. Any API, you need to start considering. You need to design it. There's a reason for this, is your API is going to be long-lived. When you hand it to people, you're promising things. And you want to design it for both human and automated users. In the ideal world, obviously, someone's going to program code against your API. That's an automated user. However, the person who codes that client, that software, is actually a human being. The business might not think developers are human beings, but they are. And they want to be able to read the kind of API and understand it. So SOAP and XML were not the easiest things to read. I think everyone can agree they weren't the easiest things to read. They were really good for computers to read because they had schemas and all sorts of validation. It was really neat. One angle bracket out of the way and you were knackered. And it didn't read, so JSON has won. So let's get over that and handle the fact that everything's now probably in JSON. And while you have a model on the server, it may not fit all your clients. So are you designing for the server? If you're a back-end dev, you'd like your server API to be nice and clean. But if you're a front-end developer, you don't want to make 20 calls just to get all the documents on your recents list. You'd like it to be one call. So you've got this balance of security, reliability. This just looks like you're writing normal code and planning something ahead of time. At Huddle, we have an API design Slack channel. So someone says, I'm thinking about writing an API, new endpoint. I think it should look like this. The front-end guys come in and say, well, that's going to be a pain in the backside because we're going to have to call it from JavaScript, and this might be, we need the edge cases dealt with, and we don't want to have come back with 1,000 items because when we link it into Knockout or we link it into React, that's going to be slow to render, so we want it paged, and this whole discussion goes backwards and forwards in the Slack channel for at least 2-3 days before we start writing the code. And that's because, as I said, an API is a contract. You are basically promising, as a publisher, to a consumer, a set of obligations. So when we create an API, we've got to document it. We've got to document responses, the headers, what you can send us. We even put sample code to show you how to use it. And we make it clear what you can miss out and where we might add things in the future, but don't bet on it. But we've got an eye to the future. And you've got to consider whether mobile or web behave differently and want to cache differently. And when you're using someone's API, one of your jobs is to read the documentation and see how, and hopefully they've written it nicely. One of the nicest things in Huddle is to see a developer moan about the API documentation for some third-party library, at which point I can point out their documentation for the API they wrote and how bad that is, and maybe they'd like to improve that because now they're on the other end of the documentation. And the other advice I'd give you as a consumer is if you only need 3 or 4 items of data from a response that has about 20, only use the 3 or 4. Don't code against all 20. So don't overconsume the result. The API might not be precisely what you want, but there's no need to have an object model on your client that has more data than you need. Because if anyone actually changes their API and changes one of the fields you're not using, you don't want your code to break. And documentation is key. So there's wikis, Swagger, Apiary. So just include as much information as you can for a developer. Try and think how you would like to read documentation if you're going to create an API. Versioning. Does everyone like versioning REST? This is one of the reasons GraphQL is caught on, is that people can't version REST. It's terrible. There is, on the Nordic API website, which I highly recommend, nordicapis.com, there's a discussion about API change management. What versions should really exist? Well, you've got a client version, so that's what the application calling it might be in version. There might be a different, effectively, version of the message format. You may have added some optional fields that weren't in the original resource message format. The servers might have a version. We've got version 2.8 of the API on this box in the US, but we're only on 2.6 in the UK. 2.8 has a slightly different message format version. And the documentation may reflect that and tell you which version you're expecting. However, the resource, that URI, the thing that had files, users, 1, 2, 3, recent items, that hasn't got a version in it. That resource is always user 1, 2, 3's recent items list. And that's important. If you ever see someone versioning by having v2 and v1 in the URI, they're not versioning REST properly. And that's why people then go to GraphQL to try and solve the fact that people are changing this API underneath them. So it's one of your responsibilities as a kind creator of REST APIs. And it's why you need to plan them, because you don't want to have to change them later. And that's how. So how do you change them later if you haven't got the planning right? Well, you mustn't take anything away. So if there used to be a thing called full name, and you've decided you don't have a full name in the database anymore, but you do have first name, last name, you can concatenate them, still hand back a full name in your response. You just wouldn't accept it as a new input field when you create a user. You shouldn't change the processing rules. So you shouldn't expect that if I then post this data, I'll get a completely different response to how it would be dealt with. And you mustn't make optional things required. So you're trying to add things optional. It's kind of like nullable in a database. So think of a database where you add a new column, but you want old code to be able to read from it. You'd have to make the column nullable, and you'd have to make it capable of or have a default value so that all the code works. And one of the things you can do is you can monitor who's using your API. This is actually quite key. Who here who has an API knows exactly who's calling what on their API? Only a couple of people. So there are lots of people creating APIs, but you don't know who's calling which endpoint and which customers are using it. If you don't know the customers who are using it, you can't take away an API feature because you don't know if someone's using it. The nicest thing we have is we know exactly who is using our APIs, and if we discover it's only the website that we own, we could change that API. Because no one else has called it in 6 months, we're the only users of it, we can change the website, we can change the API, and we won't break anyone. If the only people using it is our iOS and Android clients, we're stuffed, because getting people to upgrade all their applications on their phones takes about 6 months to roll out to everyone. But the moment you know that everyone's rolled out, you can then drop your old API. So the important bit here is to tell people when you're going to stop using an API. There is no point saying, we'd like to stop this API because it's really painful and hits our database hard, but we can't stop using it because we can't just kill the API because people are using it. The most important thing you can do at that point is tell everyone who's using your API that they have 6 months to get off it. Because until you tell someone it's going to stop being supported, you can't start a timer to get rid of that API. So the most important thing is to bite the bullet and tell people, we are going to stop using this API in 6 months, you have to move on. And how do you introduce breaking changes? Well, it's this idea, if you take clearly, what we said before about what you're allowed to do, you simply, if a change to any of these would cause a breaking change, you've got to create a new resource. So if you're going to change the URI, you're clearly changing the resource. You can't just have a random URI hitting the system. You move the resource. If you're changing the HTTP headers or the fields that come back, especially if they're mandatory, you really are creating a new resource. Even adding HTTP methods could cause it to be a new resource. You might get away with it where some things were read-only, but now they can be edited. Things like that. And changing any links. Basically, just think, if an existing client doesn't produce the same results, you've probably broken the API. And you can't expect a client necessarily to handle new data items or use different or additional methods to perform operations. If it didn't know you could edit something, how is it meant to know to put an edit button on and allow the user to edit? So you've got to start with some patterns and strategies in REST. One of them is deprecation. So clearly, the best way to deprecate something is to just hand back a 500. server error. I don't think so. That's a bad way of deprecating APIs. There are much more elegant ways. So who here has used capture? The thing where you have to enter letters or pick cars in a picture? Yeah, that kind of thing. So that was created by Google, and in March of 2018, they were going to deprecate version 1 of it. So they said, we're going to rule out version 1. For the 2 months before they pulled that API, 1% of real users hitting our website would get this. So Google told end users that they were going to stop supporting version 1 and gave a URL to tell the site owner to go to on how to upgrade. So Google told real users of websites how to get in touch with the website owner to get them to upgrade the capture. But if you hit refresh, it allowed them to go in anyway. So Google got end users to tell owners how to do stuff. If anyone was lucky enough, unfortunate enough, your view may change, to have a Windows 10 mobile, you would have found that Groove Music stopped working at some point because they gave up on the music service. Because they no longer had music, they couldn't do a detection of what song was playing. You know, like Shazam, it can tell you what music's playing. So Cortana used to be able to do that. And then one day, when you tried to get it to guess what the music was, this came up. So instead of just having a server error and crashing, any song you try and recognize with Cortana comes back with a title of Song Unrecognized on an album this service is retired by the group Music Continues, which means that people, even an end user, can kind of understand what might have happened. And it wasn't just Windows 10 Mobile, by the way. This happened on Windows 10 for Cortana as well. So Windows 10 could detect what was playing in the background. That's an elegant way of retiring an API without breaking the client, without breaking the application, but letting the end user know you're probably not going to get anything from this in the future. So one of the other ways you kind of retire an API, anyone heard of BFFs? Backends for front ends. All right. This is another GraphQL use case. So this is where you put up a temporary API, effectively. So you want to change the API. So what you might do is you're going to generate a new API with different resources and different semantics. But the problem is you've got clients who know the old API. Well, what we can do is create a little BFF, which is a lightweight API for those clients to talk to, that understands the new API, calls it in the background, but reformats it into a suitable version 1 of the resource. So instead of putting V1 and V2 in, we have a completely new resource. We moved approvals out of the files team and went into the tasks team and went into a completely separate database. The URIs and resources all changed because the data that was stored was changed, how it was used was changed, but we maintained a BFF on the Files API so that iOS and Android clients could still talk as if they had the old API that they were talking to and keep continuing. And what we can do is monitor who's using those BFFs, who's using those temporary facades, and eventually when no one's using them, we can take them away. So those can be on the edge of your infrastructure and less well maintained. They don't need to be as heavy duty because they're not being hit by as many people. And the other one is, you might get people, another GraphQL use case, is I have a list of recent items. The moment I get a list of recent items, I have to call 20 times on getDocument to get all the document details for everything in that list of items. If I was a front-end developer, I'd be screaming at the API team, please, for God's sake, give me all the documents, because every time I get recent items, I'm going to need to get all 20 documents. Right? That's the other reason you put a BFF in the way. So you can actually provide aggregate information. If you're a mobile client, I once said to the mobile developers, you want small responses, don't you? Because you're a mobile client, you want small things. They said, no, we don't want small things, we want one big, large thing. Because what mobiles have is a really bad latency to make a call into the network. Once they've done that, they're fine with a big response. So they'd rather have one mega response than lots of little responses, because that's really painful on a mobile data network. So that's the kind of thing you can do. Now, when you do aggregates, it's much harder to cache information. So you start finding that whereas I could tell you, no, the last time you got this document, you've got the same copy, so it doesn't matter, you've got the right information. Once I put 20 documents in a list, we have much more problems with telling you, by the way, you've got everything already, you don't need to get all the data again. So one of the other things when you're using the REST interface, we said about hypermedia links that allow you to navigate to different parts of the application. The other thing you can use the hypermedia links for is to actually build your UI. So rather than have to call into our API and say, hey, for this document, what are my permissions? We don't do that. When you get a document back, we give you the links based on the permissions you have on that document. So if you are a read-only user in a folder, we will only give you read links for documents. So you will only get the read APIs. You won't get the ability to edit or delete. So we don't give you the links. And if we don't give you the links, then the front-end guys go, well, if we haven't got this link, we won't put an edit button on, or we'll make the edit button disabled. So that means you can do all these links. As I said earlier, there was a delete link. You might have an edit link. So by putting these links in, you can build a user interface based on the responses from the API. It's really cool. So that reflects the permission you have on a document, the difference between a viewer and an editor, maybe even a publisher. So we don't need an API to handle permissions, where you're explicitly saying, what can I do to this document? Now, we use this is a bit of real-world stuff. There's a limitation to this, and it's our fault, because we created this API a long time ago, that we did not just return links based on your permissions. We also return them based on the state of the document. So you can lock a file in Huddle for editing. So you say, hey, I'm editing this file, it's mine, no one else should edit this while I'm working on this document. And that stops people working on multiple copies of a Word document, all trying to upload it at the end. The tricky bit with that is, we decided not to give people an edit link if someone had the document locked, which was fine when we had pages that we refreshed. But we went and changed our model. We went to a single page application. So we have a single page application that can receive a WebSocket notification. So it gets a push notification. And without the page being refreshed or any user interaction, it can work out, you can now edit the document. Only it never had the edit link because someone had it locked. So it has no way of showing the edit button now. So it knows the document got unlocked, but we decided you won't get an edit link if it was locked when you first went to the page. So we screwed ourselves up. So they now have to, when it goes unlocked, get the whole document resource again just to get the edit link so they can re-enable the edit button. And what we should have done, really, is add another rel link saying you could edit this document if it's unlocked. And have that different to the edit rel link, which indicates you have no permission ever to edit this document. And we could extend that API. This could be an optional link that we add that our front-end guys understand, and that will enable them to program it while every existing client works fine. They all work on the existing model and just have to go and refresh the document data. So who uses 304s and caching in their APIs? Ooh. People really like this who use our API because they get much less data back. So 304, we do at Huddle by using last modified and if modified since headers. So we basically, every time you get a response from Huddle, there'll be a last modified header. It's got a unique date time. It's actually the date and time that we first ever gave a response to someone in the last 48 hours, because we use Redis that expires our headers every 48 hours. It's not the last time the document was modified. If you want to know the date and time that a document was modified, you go into the JSON and get the updated date. So we have last modified. So a client, a consumer of our API, says, hey, I'll just stash the last modified date for that document. If the user hits refresh to get the latest document, then we'll send that last modified in an if modified since to the same API. I'll do get document. I'll give it the same date time I was given when I first got the information. And we can then return 304 and say, hey, no one's edited this document since you last had the data. If you've kept all the data for that document, which we assume you had because you gave us an if modified since, you don't need any data off us. You can just use the data you've already got. So that's the stuff in your local repository. On the mobile clients, it's whatever's in SQLite databases that are on the mobile clients. And that means we can return 304 within about 10, 20 milliseconds because we never had to hit the database. And we also never had to check authorization or any of the permissions, because what you're saying is, I was given this at some point. Has it changed? No, then that's fine. You had it at some point, so you already have the data, so we don't need to check your authorization. So this really reduces the load on your servers. The other thing you can do, if you don't just do last modified dates, is e-tags. One of them is an entire hash of the response to work out this definitely hasn't changed since you last talked to us. If you do that, you have to go to the database, get all the data, hash the response, do a lot of work. The weaker e-tag has a version. Effectively, you're hashing the version number. So if you are very strong on versioning your data, your domain entities in your database, you're OK to use versioning and just say, hey, you had version 4, we're now on version 8, you need to get new data. We use Redis to do all this. So we hit Redis and just say, for this document, what's the last date time? If it matches what they've given us, we don't need to go to the SQL database. So in a real-world example of how we use this, and one of the problems we hit was, I said we moved our approvals from one system to another. So one of them was, actually it was notifications. We had notifications for mobile clients, and we were moving them out of one database into another. The BFF replicated the existing API of how notifications worked. They decided not to include a last modified header. And because of that, our iOS clients went and hammered our server, going, well, I can't cache this, I can't cache this. And they were checking really regularly for whether they had new notifications. So we went back to the team who created the BFF, and they had to recreate a header, last modified header. They claimed, quite genuinely, they hadn't changed the API. And we had to point out, if you change the headers, you've changed the API. Although it's a side effect, it caused them to get hit very hard by our mobile clients. And they said we should fix the mobile clients and use the new API. And as I said before, to update everyone's mobile clients takes about 6 months, which is probably longer than the business need to get this move to a different database. So yes, you can't, and if you have external customers using your APIs, 6 months is about the minimum you can ask for them to all update their APIs. If you really force people to update their API calls regularly, they'll probably stop using your product. Right? That's the result of you causing them loads of grief, because they might not have a team of programmers and developers dedicated to doing that API and making sure they can handle new things. Anyone use 429 for rate limiting? No. Oh, they do? Woo. This is really cool. If someone's quite chatty, and we have one customer at Huddle who is very, very chatty to us, we rate limit them. We say you can do about 50 calls a minute. If you go above 50 calls a minute, we're going to tell you to back off, and we'll tell you when to come back in. And that's to preserve the service for everyone else. It's exactly like the guy who's on your broadband on your street, who's got an entire Tor download on their box and is streaming it all out. They eventually get rate limited so that everyone else can watch things on Netflix. They can't nick all the bandwidth. And this is exactly what we do at Huddle. If you're doing file requests, someone was iterating through entire folder trees to make backups of files and check what had changed. They hit the API so hard they were affecting normal users. So we just rate limit them now. There is a responsibility if you're a consumer of an API. If you see that someone's going to give you a 429 and they're going to give you a retry after header, try and obey it, because there is very little point in ignoring the retry after and keep hitting the API, because you will just get 429. So there will be no benefit for keep hitting it to get 429s. even if you have bad consumers who keep hitting you and getting 429s, it's probably better than them hitting the database. You'll still reduce your load on your servers quite considerably, because the chances are it's something like Redis that handles the 429, and that's a really fast thing to access compared to hitting the database. One of the other things we've got in REST as a nice pattern is the async model. So this is a pattern for a long-running REST call. There are times which someone might post you some data, and it's going to take seconds to come back. And I say seconds, not even minutes. Definitely we have ones that take minutes as well. If you post a 1 hour long video into Huddle, and it's full DVD quality, it will take 10 minutes before we'll be able to create you a lightweight preview file. And we do this progress endpoint pattern. So you will post data to us. One of them, by the way, the most common use of this is for search. You might post a query saying, here, I'm creating a new search, effectively, and you give me a link that tells me how my search is going. And you will wait until that link says, hey, I've now got a result. And that result may either be returned to you directly, or it's a link to where to go to see the new thing that's been created. So for a search, I might have a very complicated search that's going to take like 5 seconds. I can hand that in, poll this progress endpoint, and eventually it says, hey, search is finished, here's the link to go and find the results. Once had one of our C# guys, when async came in, and everyone got excited because you could call ASP.NET web APIs asynchronously. Anyone done that? Where you can kind of call in and it all handles it asynchronously on the server. He actually asked, please, can I have an async call which returns immediately control to the client so that my server's freed up and we can accept more connections, unless, of course, it goes wrong, and then I want them to get a HTTP status code that's an error. Well, you can't do both. You cannot hand back immediately and then go, but in about a second there's an error, so I'll now give you the error, because you've already let the thing go. So this progress endpoint is much better for handling this, because you get a 202 accepted, you go to the progress endpoint, eventually the progress endpoint completes, and that may take you to the real results, or it may take you to an error. That something happened, something went wrong, you can't do that. The other reason that GraphQL has kind of took on quite as much as it has is, if I have a huge resource and I want to edit one thing in it, one little property on it, and it's a property that doesn't really version that domain object, I have to still post the whole of, or put the whole of the document back. And that's a bad thing. So if you only want to update a tiny bit of an object, you could do patch. I don't know anyone who really gets patch and enjoys using patch. It is one of the things that REST people say, we could do patch. And you go, or we could do a put and a post on a child resource. That would be much easier. So things like changing something from read-only to editable might be a mini put. We can just go to the document and say, I'm not changing the title, the description, the content, anything grammatic about that document. I'm just changing whether it's read-only or not. That's a good case for doing these mini puts. And you may, after doing these mini puts, return a full version of a document. So you may say, hey, I'm going to change the read-only status, and when I hand it back, I give you the full document resource, which means you can now refresh your UI with definitely what the latest state of that document is. Or you may say, hey, if you want to find what the latest document is, here's another link, and go to that. So you've got either option. So real-world examples, this is a thing that we've got in our backlog. So we have file requests. We have the idea of a task where you say, hey, I need someone to load a file into Huddle, so I'm going to send them a task, a little to-do, saying, please can you put this file into Huddle? And there's a status on it. And our REST model isn't very friendly to the front-end guys. Because if they need to update the status, the first thing they have to do is get the latest version of a task, so they make sure they're not overwriting something that someone might have changed. They then have to put the version of the task with the new status value, and then they have to get the version of the task to make sure it all stuck and now they have the latest version of the response. And what they want is just to put. That's it. They just want to put a status and say, hey, make this finished. And when you do that, give me back the whole of the task. And if in the meantime someone has slightly edited the task, put on another person, or edited the title because there was a spelling mistake, it will come back and I can reflect that in the UI, but I will have changed the status in the process. And therefore, you've reduced server calls. And more importantly, you're actually doing what the business case is. The business case is to change the state of as a task. It's not to resave the title, description, all the task users, all the links associated with it. So I mentioned earlier that as a user or a consumer of an API, it would be really nice if you only use the bits you need. Right? That protects you against weirdness. Just because a response includes loads of JSON, you don't have to deserialize it all into an object and then store it in a local repository, especially on GET calls. So a real-world example, we have Huddle Desktop. Huddle Desktop runs on OS X, and it also runs on Windows, and it allows you to just click on a Word document. It opens via Huddle Desktop, opens Word. We monitor whether you're editing the document, and we upload it for you automatically in the background. So every time you make a change, we upload it. It's really nice. When you log in, it loads all the information about the user who's logged in so that we can have your avatar in the corner, your name. We know what workspaces you can use, a load of information. It also includes your personal website, a web address. At no point does Huddle Desktop use the website address. At no point is it shown in the UI. It never gets used. But someone decided to deserialize it into a full object model. And because it was a website, they decided to deserialize it into system.uri. A QA put random shit into the personal website. You could not log in Huddle Desktop anymore for that user because it couldn't get it into system.uri, and no one put exception handling around it because, my God, this response has been used forever and it always works. And the annoying bit was, it was added for completeness because we might use it in the future. I'd say the worst thing you can do is add code to your code base because you might use it in the future, because you're now dependent on any changes that might happen in that API. In another one, the Android guys fell into a similar trap. So we had to-do lists, and we had file requests, but originally we just had simple to-dos, and we had approvals, and we added file request. And they had a case statement, and they said, if it's type task, set it to this type. So they're grepping the string we hand back as in the JSON response. If it's an approval, it's an action type approval. If it's not one of those, I'm going to throw an exception and stop working. So we had file request as a new type of task, and Android shows you all the tasks you have up to the point there's a file request and then stops. And the list just stops halfway down because it throws an exception. So clearly, there are two ways of dealing with this. One, I have a task type I don't know, so I just ignore it because I can only handle to-dos and approvals. I can't handle file requests, so I will not show them at all in our list, which is what we eventually coded. One of the other things you could do is at least tell the user, we can't show you everything because there's stuff in here we don't know about. And that's fine. It's fine for a client to go, we've always dealt with to-dos and approvals, but we can't do file requests. Eventually we'll code it, and then we'll put it into the app. What you shouldn't do is stop rendering the list halfway down. And remember, by the way, we wrote the APIs, we wrote the app, and we can't write the app to our own APIs. And we're in the same building on the next desk. So just think how it is for consumers of your APIs when you're creating these things and changing things. Another thing the Android app decided on was, I will look at the links that come back in my JSON response, and the first one is always the self link that I can put my data to. I won't look for the word self. I will just assume the first link is the link that I can use to update a document. When they wrote the BFF, not only did they change the last modified header and miss that out, which we then fixed, they found that the Android app cared about the order of links in JSON. There is no way you should be dependent on the order of data in a data file. You should be looking through the object tree and looking for the words. So we had to change the order in the BFF because it takes 6 months to update all the Android clients. So we had to fix the API, not the client, and then fix the client anyway, so in the future it won't matter. So be specific as a consumer. Now, this strictly isn't a REST API, but it was the most laughable bit of code I'd ever seen. So I had to include it in a presentation at some point, and it is what you shouldn't do with these kind of responses. So, Huddle Desktop needs to know if the internet's gone down. Now, getting errors to talk to Huddle servers does not mean the internet's gone down. It may mean our servers have gone down. You know, it's quite possible. Even though our SLA is 4 nines, our servers may not work occasionally. It is, you know, there may be a DDoS attack on someone in our data center and it affects us. It's obviously not our code. Our code would never go wrong. So you want to check some alternate destination. You could be mad and go, I'll check Microsoft or BBC or some big company that's never going to go offline. But instead, we went to an S3 bucket that we own. And we'll go and look for a file called ping. If it comes back with pong, bingo, we're in. So if we think the network might have gone, we check whether it really is the network or whether it's our servers. So that's fine. So clearly, we want to go to S3. We're going to check that a file exists, and it should have this response. So what you do is you say, is the network available? Yeah, it's less than bad request. That's an enumerated value that just says, basically, if it's less than 400, it must be there. Insane. And don't check the content. Don't check it was 200, which is what you really should have checked for. And oddly enough, when you do that, we actually found that the S3 bucket we were using was also where we published public files. When we took away the file, the server says, ooh, I should do a 404, but our rules in S3 are don't do a 404, return them some JavaScript as a 200 that tells them, redirects them to our website because they've tried to get to a public file that doesn't exist anymore, so we want them to go to our website so they have a clue what's happening. Which meant we got 200s when we returned the file, and we didn't return Pong, but the client didn't know, so we couldn't shut off the desktop clients when we had a severe load on our API and we wanted to kick out all the desktop clients. So that's just a clear example of how you really shouldn't be very general with how you treat your responses. You want to be very specific that I'm only going to work if I get the right thing back. So yes, so now we look for HTTP status OK. We also check the content of the response. After this, we also found that, you know, if you're talking to a client, a real customer of our software, and they're trying to work out whether desktop's got a problem, we're having to say, well, what you want to type in is this address with the word ping in and see if it says pong back. And we decided that's a bit embarrassing to tell customers. So we now actually have a proper response that says this file is for testing network detection. We've also made it so there's multiple files, so we can actually phase in desktop over 10 files and things like that. So we've got a much more complex way of dealing with this now. Still in S3 buckets, but we now understand what the problem is. So yes, so those are the pitfalls we've had at Huddle. So, resources for REST APIs. You could go to the original Roy Fielding doctorate, which is an interesting thing to read, because this is someone thinking, how can we do an API via the standard HTTP methods and verbs? The Nordic APIs site is a really good discussion of everything to do with APIs. And including that, I'd also add the Slack channel. There's a slack.httpapis.com. These are both places where if you chat to them friendly, they'll actually discuss how your API should be designed. Is this a good way of doing it? Are there better patterns and practices for creating your API? These guys want you to create a good REST API. They've seen enough bad REST APIs, and they want you to help you make a good REST API. So let them help you. bizcoder.com has a really good set of HTTP REST patterns. We're basically REST has had a problem of no one really published patterns. There weren't established practices. It's like there was no real methodology. I think we're getting to the point where REST has known patterns, known practices, known ways of dealing with things. This is the point at which maybe we can just push it that little bit further and everyone will understand what's happening. And they won't all run to GraphQL or gRPC because it's not that hard once you do this stuff. And the REST cookbook has really good guidance on how to create RESTful APIs and the basic fundamentals of REST. So the problem is, if you get RESTatharians arguing that's not the way to do it, this isn't how you should post or put, it can put you off initially. But it's worth it in the end, and you get a very elegant API that is kind of really readable and predictable. And if you harmonize it across your whole API, developers are really happy that the same responses come back from different APIs, whether it's files, tasks, we do progress endpoints and things like that, and they get really used to using it, and it becomes second nature how they talk to the API. And that's a really good thing. So, that was my talk on REST APIs. I occasionally blog over here, and I'm occasionally on Twitter. And if you want to find out how to get a job at Huddle, you can look at huddle.com about careers.huddle. I'm obviously put Huddle a lot on these slides, but Huddle, this is part of my 20% time at Huddle, where they allow us 2 days every fortnight to work on presentations, community stuff, open source, and side projects. So it's really good of them to allow me to come here and not use up annual leave to talk to you guys. So I'm always grateful for that. Any questions? Yeah. Yep. Why don't you include the verb or what the model would look like? Okay. So the question there was, how in our REST responses, in the JSON response, we have a set of links. One of them was called self, I think, would be the real one that stands out a mile away. Self link. How do we choose what names to give them, and why don't we just have a put, post, the things you can do? With the self-link, there are established patterns in REST. We always try and use links that people have used before. So the self-link, if we have no worries about creating a UI, that self-link can be used for put, post, delete, the whole lot, and get. So by doing self, and we give you no other information, we're pretty much suggesting you can try any verb on it. So now we have a terse response that says, hey, here's what represents a user and all their details. You can get it, you can put it, you can post it, you can delete it. If you're not allowed to do something like that, you will be told to go away. Right? It'll be either forbidden or it'll be unauthorized, something like that. So not every API is designed to build the UI from it. So for the get document, we have an edit link to show that you can have an edit button and you would be able to delete it. But not all our APIs are designed like that. So that's why we don't actually put the verbs in, because it may be that you can actually use more verbs, all 4 verbs on the same resource, and we don't want to repeat that bit of data in the system. The other thing we do as well is there are times at which it would be nice that a system has a document ID, but they aren't the file system, and they would like to be able to create a URI in their own responses. So we do have templating of URIs. So we can say, hey, here's the URI to edit a document, and you've got to put a document ID in here, and you probably know what the document ID is. So rather than have to hard code every URI, we'll give you templates that you can fit in the IDs. And that's to stop clients, which happens quite a bit, assuming that they can create their own URIs by just sticking in the right IDs. So that's the other strategy for trying to simplify the response. Does that answer the question? Yep. Any more questions? Yes? Well, it's interesting you should say that. So that was a comment about our content type in all the examples of application/JSON. That is not what we return at Huddle. We return application/VND Huddle JSON, we specifically return not the default JSON type, but I wasn't going to put that into a presentation because you're going, what the hell is that data type? So we actually do use our own data type to indicate this is a specific schema we're really thinking of. This isn't just random JSON. This represents something in Huddle that is a document. We've also used, you can use media types for versioning. This is a slightly evil thing. So you can say, hey, I want to get JSON, the version 2 of this resource. But you're now starting to really twist, because that's almost like you're putting the version in the URI. You're getting close to that. Now, we do support different data types, so we will say, if you have a document, so this is content negotiation. We have a document in Huddle. If you want to request it as a download, you can get it as a docx, Word document. But you can also ask for application PDF, an application TXT, and you'll get a text version of it or a PDF version. So we do content negotiation. We happily do things like, I want this as a CSV file, and it will format it as CSV, rather than returning it as JSON. So there are specific cases where we actually return a different format of the same data, but it is the same resource. We aren't adding or taking away anything, so we're not using it for versioning. There was one case where we used it for versioning, and then we decided it was a bad idea and we really ought to create new resources. But that was a personal, internal discussion that eventually went, we don't want to use content types for versioning. It's not really what it's meant for. Content types are meant to return you the same thing in a different format, not a completely different thing or a very much enhanced thing. So we decided to not do versioning in content type. OK? Any more questions? No? Well, thank you very much for coming to the first session, and I hope you enjoy the rest of the conference.